Good morning. Morning. Let me take a moment to introduce myself. My name is Randall McDowell. I am the Senior Director of Business Development for DBI Consulting, and we are absolutely thrilled. We're absolutely very proud to be a key sponsor of today's conference and, of course, a key sponsor to the Innovation Track presenters here today. Obviously, as all of you well know, today's conference is, of course, all about architecture. And since 1988, DBI has been at the forefront of technology and business architecture. You won't find an organization with a deeper level of understanding of what true architecture is and what it means to your organization. At DBI, we're going to help you understand the myths and realities surrounding architecture. And we also have a deep level of experience and expertise to help ensure business value from IT, which, of course, is so critical. Our presenter today, Aditya Thadani, will also be talking about just that. His topic today is realizing business value from the convergence of big data and the Internet of Things. Is that correct? Very good. So I'd like to introduce you to Aditya Thadani, but before I do, I want to give you just a little bit of background about him. Very impressive background. Aditya is a business technology executive with international experience, currently working as Chief Enterprise Architect at Ecolab. He specializes in developing actionable strategies and driving execution and innovation business transformation initiatives in large enterprise environments. Aditya has a record of delivering results in the automotive, aerospace, and defense, financial services, manufacturing sectors. Working for over 7 years as the chief architect and 3 years as chief information security officer in Fortune 500 firms, Aditya has broad experience across the United States, Asia, and the European Union. Aditya holds both an MBA and a Master of Science in Mechanical Engineering. Aditya?
Thank you. How about this? Can you guys hear me? All right. Okay. Before we launch into this, I want to actually introduce a colleague of mine who couldn't join us here. He actually works out of our Chicago office, Phil Angioli. He's the mastermind behind a lot of this. He's the information architect and analytics architect at Ecolab. So a little bit about kind of how we got into this topic. As most things happen, it was a case of the problem evolving on us, and then the solutions emerged, right? We didn't start out by saying, how do we put these two pieces together, right? In retrospect, it makes a lot of sense, put these two pieces together, but we didn't start out that way. We actually approached this as really an IoT opportunity, Internet of Things opportunity, and we'll talk a little bit more about kind of how we see that in the industrial context, because a lot of it we hear about is, the iWatch, the things that we use as consumers in the B2C marketplace. But there is an interesting play in the industrial space that I think is a great opportunity for us. And then we kind of evolved into how we put the two pieces together from a business value perspective. So with that in mind, I kind of organized our discussion primarily to just ground us in a little bit of business context. Say, what is the problem you're trying to solve, right? Nifty tools, everybody is talking about those two technologies, and it's exciting stuff, but we wanted to ground ourselves a little bit in what is the business context, what problem are we trying to solve, and then go in a little bit into the technical challenges we ran into and how we went about tackling it. And some of the organizational issues, I think, which come with most new things, and typically end up being the harder things to tackle. Not that we have sorted it all out by any means, but I think we have some ideas on how to go tackle it over time. So a little bit about Ecolab before we launch into the topic itself, just so you kind of get a bit of context about our business environment. So Ecolab is a very diversified company. The kind of the unifying theme behind the company is really, as you can see, kind of our tagline is clean water, safe food, abundant energy, and healthy environments. And essentially that reflects all the markets we operate in, right? So we are in a lot of manufacturing environments that use a lot of water, whether it's paper, pulp, mining, Anywhere you see cooling towers and boilers going on, we are there. We are on the right side, we are in oil and gas, meaning we are in refineries, we are in oil drills, shale operations. And then in kind of a newer sector for us, a growing sector for us is essentially bringing similar solutions and technologies, but in healthcare environments. So you would see us now increasingly in surgical environments as well as point of delivery and in hospitals and clinics. So kind of where does IoT fit into all of this from a business perspective? If you look at Ecolab history, we are, I guess at the core, we are a chemicals company, right? That's what we sell, chemicals. But from a customer's perspective and the market perspective, what we are really delivering is solutions and services around those core products. Right? That's kind of what is our differentiating strategy. If you kind of look a little bit at Ecolab's revenue growth history, you can see a big spike over the last 3 years. Right? We kind of over doubled in size. We are at a good clip rate of about $14 billion this year, give or take. And some of this was really acquisition-based entry into new markets. So over the last 2 years, we got much more heavily into industrial space. Prior to that, Ecolab was much more in what you would call the hospitality business. You know, you would see us in restaurants and hotels and anywhere there's a pool, a cruise liner, places like that. And now a good more than half of our footprint is in industrial environments and in factories and plants of different kinds. And being that we are in a chemicals industry, which is notorious for being known as a commodity industry, margins being what they are in that industry, the strategy of the company has really been differentiating through innovation. Right? So our value is much more than the chemical we are providing. Right? In fact, we are helping customers use less chemicals that we sell. Right? The value proposition is not how much chemical we sold you. The value proposition is how much water we help you save or use less of, or how much energy you use less of, or how much asset life we extended for you from your capital assets perspective. So that's kind of the value proposition. And that's driven a lot by innovation in products, innovation in services. And I think this is an interesting play. If you look back over the last 10 years, a lot of our innovation was in new products that we created. As we move forward, I think we're seeing much more innovation in services side of the business. Right? Ecolab actually has a very interesting position from an innovation perspective. It's recognized in the Forbes list. Those of you who are familiar with it, Forbes publishes, I think they started 3 years ago, publishing a list of most innovative companies. And Ecolab has been, right, I think 2011 or 12 is when they started, and Ecolab has been in that list consistently. One thing that actually kind of shows how serious we are about innovation as a part of our business strategy is that we measure what we call a vitality index. That's a part of our KPIs for the CEO, right? And what that really measures is how much of our revenue is coming from newer products in our portfolio than older products in the portfolio. I think we use like a 3-year and a 5-year mark to see what our revenue generation is from the newer product introductions. So clearly with that in mind, kind of you can see how we are constantly looking for opportunities to differentiate and create new services around the basic core of our value in the market. So if we kind of go look at the industrial sector, and these are just some of the examples in the industrial sector. So just to give you an idea, on the bottom right, we sell solutions and cleaning solutions in bottling plants, for example. Right? On the top left, you see our footprint in oil and gas. We are in upstream and downstream. Right? We are both in extraction points as well as refineries. Right? Pretty much the entire chain in oil and gas. And what that really has created for us, if you think about it, is that we have these devices which were engineered to deliver specific chemical applications in these environments. And these devices are distributed all over the world. They are in our customers' environment, right? So you would see it in a bottling plant. You would see it in a dairy. You would see these devices in an oil rig, right? So they're kind of all over the place now. The devices are, of course, very application-centric, so there's a lot of variety, and that kind of presents some of our challenges, but does create an opportunity that in a lot of cases, we have devices that have more information about our customers' operating environment than some of the people working there, which is not unheard of, right? We see that in SCADA environments all over the place. And interestingly enough, that's kind of what our motivation was, that more than how do we capture information about our manufacturing environments, we wanted to know more about our customers' operating environments and how we can create value from that. So these are, probably those of you kind of who work in the industrial space see these kind of opportunities very obviously. One of the, I would say, the kind of low-hanging fruit from an IoT perspective, when you want to say, how do I get some value out of the devices that are there, the most natural thing is devices are monitoring, so I can create alerts, right? Just create an op service. So, most of us in IT are familiar with a NOC or a SOC, and you can imagine a NOC-like service that you can build for a manufacturing environment and say, I'm going to monitor all your sensors and give you alerts on when things go out of hand, right? That's kind of was the starting point for this conversation. When you start to kind of go beyond that, beyond the alarms, let me react to the exceptions, you start to see that there is actually so much more information in these devices, in these sensors that's getting captured, that was 99% of it was essentially being ignored. Nobody ever saw it, right? If it was not an alarm, nobody ever looked at it. And that's kind of creating an opportunity. So what's in that 99% or 99.9% of the information that we can use either to create a better product offering, right? Create a better chemistry in our case, or to actually advise our clients on how to optimize their operating environment, right? How to reduce their downtimes, how to, going back to our kind of core ideas of how do we optimize the use of scarce resources like water, like how to use less water in a cleaning cycle, things as simple as that, right? And then the last piece is really saying, okay, if those information services and assets are there, how do we actually start to monetize it in its own right? And that's actually something, to my mind, very new from an industrial sector perspective, right? We've been seeing that in a lot of different industries like S3 doing it, or GPS-like services doing it. But when you put that in industrial context, essentially selling information services is kind of a new thing for us. I think as a sector too, I believe. So a little bit about kind of how we went about looking at IoT was from a conceptual architecture perspective. Fairly straightforward, right? We have been deploying on kind of the bottom right, you see the sensors and devices that we have been deploying for, years, right? They have been around for, now, till recently, most of these devices were operating as standalone devices. The only thing that they connected to was the machine that they were controlling, right? They were sitting in an environment, in a customer's operating environment, and they were not talking to anybody unless somebody walked over to the device and plugged the cable into it. That was the extent of connectivity. So I think over the last few years, one thing we saw was that the cost of connectivity and transporting data, they're cheap, right? Or at least, let's say cheaper than it used to be. It's getting cheaper all the time, but it's certainly, there was a shift in that price point. So that created an opportunity to say, okay, so in the past, we were moving only the exceptions, 0.1 or 0.01% of the data, probably even a smaller fraction of the data. Why not bring it all? Now we can afford to, right? Afford to was a tricky part there. But once you kind of start to see that you essentially have an explosion in the number of network devices, right? Devices that never talk to anybody suddenly have information to give us, right? And we kind of shifted our model from we don't know what the devices are telling us unless we take it all and start to figure out how to parse it, how to make sense out of it, right? So in the past, when we said, just send me the 3 bits that I know I want, we said, no, give me all the bits you got, right? So capture everything you might want and need. So once we started to kind of move all of that data, that created opportunities like creating a NOC-like service I talked about, right? So the most obvious thing is if you look at a pool and spa service from Ecolab, for example, one of the things we do is it's monitoring the water chemistry, the pH level, and some of the parameters. And if it goes out of band, it tells us, and then we trigger a service event and make sure that a remediation action is taken in that location. Right? That's just a very simple example. But in industrial context, you go into a refinery or a boiler or a cooling tower. We again monitor the chemistry and kind of how to make adjustments to the operating environment to optimize that. Then the next thing is, okay, if we kind of say we are reacting to the alarms, how do we start to predict the alarms? That becomes the most obvious next opportunity. Right? So how do we predict the alarms? And then the third part really is, I think, which is transformational for us as a team, is how do we take that information, so much rich information about the operating environments where we put our solutions, and use that to drive the next generation of products. So what is the next generation of products that'll differentiate us in the marketplace? So this is kind of just some of the industry trends, and this is not necessarily Ecolab specific, but most probably you guys have all seen these predictions of how many connected devices there are going to be, right? This one I borrowed from Cisco, the one on the top left. It's saying 50 billion devices, connected devices by 2020, right? So clearly a big explosion, and then of course all of us are contributing to that 50 billion over time, right? As individuals, but also as companies deploying these devices. And in most estimates I've seen, actually, interestingly enough, a lot of these are driven by the very visible shift in connected devices in the B2C marketplace, right? What we carry as individuals. I believe that there is actually a latent set from the industrial environments that's not showing up here yet, right? We have been, for decades, we have been deploying these PLCs and SCADA devices in our manufacturing environment. Everybody does, right? And oh, by the way, the security architects amongst us were very cautious and told us not to let that bleed into our corporate network, right? We kind of isolated those environments. That's how we protected it. We isolated it. Well, they're all going to get connected. So if we kind of look at that, give or take your number, 50 billion, 20 or 70, whatever the number we pick, it really then shifts that, okay, we solved one problem, we created the next problem, right? And to my mind, the next problem is we still don't know what to do with it, right? We connected all the devices and it's telling us everything, and everybody's, people are tweeting it or putting it on Facebook or whatever, whatever you want to do with your wearable. We are still kind of figuring out, especially from an industrial perspective, so what? Now what, right? I mean, intuitively we believe that there's an opportunity, but we haven't figured out ways to tap that quite effectively yet. Right? And I think that's kind of, to my mind, where the technical and organizational challenges are here in the last 2 years and the next 2 years, where we kind of work through that a little bit. So that kind of, at least, brought us to the obvious revelation. Oh, we got tons of devices and tons of data. Now we got to process it. Right? And then that's kind of how we stumbled into it in a way, right? We always had a data processing environment which was gathering and processing sensor data. And once we started to open the fire hose, we suddenly realized we needed to solve that. The technical problem essentially just shifted, right? It shifted from devices and connectivity and telecom contracts and reliability to what happens when the data actually makes its way to us. So there are three things that kind of very obviously to my mind, which makes big data in retrospect, I think no-brainer, right? Why didn't we put the two together? And the three things really are volume, clearly. We got gobs and gobs of it now, when we had a trickle coming in the past. If you look at the amount of data we capture from sensors and you compare that to most enterprise environments, enterprise meaning your ERPs, your CRMs, and it's order of magnitude at least. This is when you start out, right? If you have been doing it for 5 years, this will keep exploring. Right? It'll far outstrip our sense of what volume looks like if we are used to seeing data from an enterprise systems like a CRM, ERP, and you name it, system that we support as IT teams. The second piece is it's coming in fast and furious. Just over the last 2 years, we have kind of squishing the time at which we take snapshots from devices. It used to be hours, we are down to a minute, right? So it's coming from all those devices as fast as you can digest it is the point. Variety, and this is actually was a little bit counterintuitive. So mechanical engineer myself, so always thought machines were very structured, right? They have very concise, precisely constructed messages. They do. It's just that when you have 1 million machines, each one constructed differently, it starts to look like a lot of noise. Right? So the variety, even though we kind of over the last few years we've kind of seen variety come out of the social data, right? People chatter. What we're finding is that machines, because of the way they were designed, and sure, standards and all of that, but they all kind of were purpose specific. They captured and sent data for a purpose, and they all made up their formats. So now you're left with dealing with a legacy of devices, and you're saying, we need to figure out how to process all of this, right? Not for one application, and especially for Ecolab, which is kind of, you saw a little bit of the diversified nature, right? If you are in a dairy and a beer plant and an oil rig, you bet the data looks different. Right? So we kind of put those three things together, and it obviously looks like, well, that's how we want to solve it, right? Big data becomes the obvious platform of choice to go tackle the problem. And I think this was actually, when we talked to people outside the company, was an interesting shift. If you look back at the history of Hadoop, for example, right? I mean, go back 8 to 10 years, right? If you look back at how the platform evolved, it came out of the search technology, or at least it was developed primarily as a solution to the search problem, right? Indexing and search problem. And you kind of see the arc of adoption or arc of evolution of that technology. It kind of went from search into clearly the explosion of social data. Everybody wanted to apply to that, and B2C scenarios. And what we're finding is actually in B2B scenarios, we are having the same textural problem of data, not from social so much, not from search, enterprise search so much. We are seeing that come from the IoT space. But same problem at the heart of it from a technical perspective. So a bit about technical challenges in putting these two pieces together. I think before we get into the specifics, there's a very fundamental shift to my mind that is happening with this. At least something that was counterintuitive when we resisted initially, right? And we even still see with customers. What we are essentially saying is we want to take data from devices and bring it into what I would call the people universe, right? Historically, we kept devices and data from manufacturing environments in manufacturing environments. Right? We went to great lengths to isolate our manufacturing SCADA networks from our corporate data network. Right? People put firewalls if they ever connected it. Right? We came up with all kind of security architectures to isolate the two. And this is saying we want to bring it all into what I would call the enterprise or the people universe. Right? So that's a significant shift in thinking as architects, as technologists. The other part is that we kind of go back to the trend that most people, the buzzword, the digital IT. Right? I thought IT was always digital. Right? When did it become digital IT from analog IT? Right? But when you kind of peel, get past the buzzword, I think what they're really saying is they want to bring the digital and the physical or the people world closer together. Right? And I think that's an interesting shift to my mind when you think about sensor data. Right? Historically, we created sensors to talk to our machines and keep it between themselves. Right? We put them on a shop floor, the sensor talks to the machine, and just sort it out. Right? People didn't want to get in the middle of it. In fact, we went to great lengths over the last 20 years of automation and control engineering to take people out of it. Right? And now we certainly think that we can do something in that mix. And I think that's not going to come easy to people. Machines will be okay. So a little bit about the technical challenges. Again, kind of goes back to the velocity and the veracity, right? Velocity. Much faster, much more. If we kind of look at the before was capture only what's needed, capture the exceptions. Now we say we want to capture all the data you got. Right? So we have to brace for that. And a couple of things I think that kind of from my perspective that stars are aligning from a technology perspective is that as we get more used to the NoSQL paradigm or whatever we are calling it these days, but the idea of don't get hung up on structure and schema when you process data, right? So we kind of look at it as, and people call it, schema-less for writing and schema-based for reading, right? So schema is really much more for our benefit than it is for the processor's benefit, right? The processor and storage doesn't care about it. We put all those schemas and structures so we could make sense out of it. Well, do it on the read. Don't worry about it the write. So that's one thing that I think is helping us. The other part is, this is actually a big cultural shift for us, is people keep talking about the pattern shifting from ETL to ELT. And I feel that that's actually much more of a cultural shift. Right? I don't think that's a tools shift. Sure, you use different tools, but I think getting people to, again, not want to get in the middle of data flows is hard, right? We want, because how did we do BI for years and years? We started with what does the business want? And we start to shape our data pipeline or supply chain or whatever we are calling it. Right from the source, we start to align with that end game, right? And what we have seen year after year after year is by the time we get to that, people have changed their mind about what the end game really looks like, what they want keeps shifting, but we keep doing it the same way, right? We keep trying to align the pipe from the source straight to the target, and then it moved again. And I think this kind of is really forcing us to do what probably we should have done 20 years ago for other reasons, is not to start transforming right at the right when we get data out of the source. Right? Get it out, bring it in, and now people are talking about lakes and ponds or whatever we're selling these days. But I think the idea has merit that we really need to sit on our hands and avoid the urge to start shaping data too soon. From a processing perspective, I think what has helped us is the maturity of the MPP platforms, right? So now we can actually do the transformations in the storage environments after it gets there and then process it there. So this variety issue actually is, I think we kind of dealt with in manufacturing environments 20 years ago on a much smaller scale, was the issue of how do you take data, the machine data, and the SCADA data, and bring it into the enterprise data environment, right? So at that time, we used to have some manufacturing data and some design data, maybe from PLM systems or whatever, and we wanted to put it together for some reasons. And there was always a certain amount of friction when you tried to bring the two data sets together. Now, those are much smaller data sets, right? We were looking at bringing manufacturing data from our plant floor, not from a million of our close friends' operating environments, right? So the scale kind of creates a challenge. And I think the true value from a digital IT perspective is if we can bring that sensor data and bring it into our marketing operations, into our sales operations, into our R&D operations. Otherwise, it's interesting information, but nobody's doing anything with it. Right? So that, I think, is an interesting shift in bringing the two pieces together. And what we found, going back to my prior comment about we really are switching away from this idea of data pipelines and data supply chains that we had bought into so heavily, right? I mean, we were talking about data quality and data supply chain ad nauseum to ourselves and to all our business peers, that's the way to do it and that's the way to think about it. But I think it really is shifting from that and not seeing it as a linear process as much as we used to. Right? So we are now actually thinking about in terms of zone-based, and there are some platforms that are emerging to make that possible. But the idea really is think about your data processing differently. And again, the computing platforms, they are getting cheaper. Those appliances, they're becoming more available. So it's certainly more affordable than we could 5 or 10 years ago in this space. So this kind of is a very high-level conceptual view of kind of what I'm talking about from a zone-based. So what we're saying really is that you got SQL data and you got NoSQL, right? You have data that wants to be structured because it came out of our ERP and it came out of our CRM systems, and data that resists being structured because it came out of your social platform or it came out of your devices, right? You pick where it came out on the left. It resists being structured. And we need to kind of figure out how to gently shape it till we get it to a place where it's consumable. Right? So we are looking at really creating these environments that are open to both model schema-based and schema-less. Right? And figure out ways and tools and mechanisms that let you go back and, I wouldn't say go back and forth, maybe more today from schema-less to schema-based is the direction we tend to go, not the opposite direction yet. But at least we really want to see how people can move across those data sets, put the data sets together in a meaningful way and make sense out of it. And I think that's the most important part, that when we get into predictive or when we get into product innovation based on this information, it really is still a very R&D-like process, which is a people-based process. Right? We are, all of us are hunting for data scientists these days, right? We want to find the data scientist and the domain expert that we can kind of plumb together and solve the problem. But really what that points to is that we really need people brains to sort out what we got in there. Right? We haven't quite figured out yet. We want people to sort it out for us. And then that's okay. So what that means is that this data architecture then really needs to understand that there's going to be a lot of interactivity. Right? It's not the days where we produce a standardized canned report and spit it out and somebody consumes it. Right? People are going to go get in there with the data. So that's kind of one thing. And so you kind of see the technical components that we put across the top from a platform perspective. I think those three pieces, to my mind, architecturally are just absolutely essential to go anywhere with that. Okay. So a bit about organizational challenges. So this is actually an interesting shift again. So in most enterprise environments, large companies, last 10 years have had multi-million-dollar initiatives on master data management and data quality and data cleansing, right? So we told people how essential quality was to analytics, right? And what we really meant was how essential quality was for repeatable analytics, right? If you're putting a report to the street, you want it to be very predictable, very repeatable, right? No changes in rules, with no surprises, right? Makes sense. If you are a line manager from an ops perspective, you want a predictable, right? But I think we kind of missed some of those pieces about predictability and repeatability. We just got hung up on quality, and we were all about quality. And I think now, to my mind, we are getting a more balanced, nuanced view of the world from a data perspective. I think we are starting to recognize that quality comes at a cost. Quality comes at a latency cost, right? It takes time to get quality, and then possibly even detail. And you kind of have probably seen curves that show kind of when an event happens to when we create an analytic product, a report, let's say, or a dashboard that a manager or an executive can see to react to it. There's usually days, if not weeks, between those two. Right? That's the cost of quality. That's the cost of getting it just so and just right for the consumer. So we really are trying to get people to rethink the idea of quality to fit for purpose. And mechanical engineering, I think we were taught this a while ago, fit for purpose, right? There are different purposes requiring different quality assurances or levels of quality or whatever you want to call that. But the characteristics of the data have to be aligned with what people want to do with it, one. Two, on the flip side, we need to retrain people and think about quality as a continuum, right? What are you trying to do? Is it good enough? Right? So that's a significant shift, and that's not just a shift for people in IT, that's a shift for people, the analysts on the business side. They have to kind of rethink about how they consume data. They are, to my mind, have to become much more informed consumers than your average BI analytics consumer who wanted to look at a pretty dashboard and get the needle just right in the green zone and I'm good, right? So that, I think, creates, from a data governance programs perspective, so how do we handle that? That's a continuum again, right? So this does create quite a bit of organizational shifts, to my mind, that we need to work through and retrain our thinking in dealing with this ambiguity now. Value. Right? I think this is the stickiest piece, because without this, the rest was interesting but useless. So here is, I think, to my mind, how I look at where we're going with this. So at the outset, I said what we're really going after is information services, right? Information-based services. We want to sell. We're not going to sell data. Nobody wants to buy it unless they're buying an email list, right? Pennies. In an industrial environment, they're not buying data. They're buying actionable information. How do we get from data to actionable information? Predictable, repeatable, actionable is almost, I think of it as creating a product the way we did as R&D people or as engineers in the first step, right? How do we go about creating a product? We did a bunch of research. We figured something out nifty that could solve a problem, and we tried to turn that into a product, right? And then we are taking that and figuring out a manufacturing process and launching a product and delivering the product. I think we need to think about organizationally the same way. How do we create the same way of producing information services out of this data, right? First, we have to let people loose at the data, those who can make sense of it, and this is where data scientists come in, right? And then the domain experts, to first see what are the insights. What is it telling us, right? It's telling us stories. We need to learn how to read those stories. That's first part, right? Once those guys have figured out what the insights are, then we need to figure out how to turn that insight into a consumable product, right? It's great as a one-time insight. How do you turn it into a consumable product that you can sell in the marketplace as an information service? That really means that you're essentially, to my mind, in the good old ways of creating a product manufacturing, you figure out how you're going to produce that, meaning is that insight going into turn into an alarm or a trigger of some sort that can be sent to somebody, or is it going to be a part of an R&D product development process? We need to work through those details and figure out, because in the end, if you think about organizations, whether it's R&D or marketing, we're lucky if we'll have one or two of those data scientists and domain experts who can dive into the data, raw data, right? They have to turn into something that the broad organization can consume and monetize. And that part, to my mind, is a gap in most organizations. If we are lucky to have data scientists, that's about as far as we've gotten with it. Right? We haven't created the organizational mechanisms to take those insights and turn those into products or services that somebody would pay for, at least from a predictive, prescriptive perspective. Everybody's favorite topic, why not to do it, right? So this is, at least in my experience, what I've seen, this is the reason why not to do it, but it hasn't stopped anybody yet, right? It's a big problem, it's a scary problem, we are all admiring it, we are thinking about it. I think the basic shift that has happened is going back to my earlier comment about how we secured industrial environments and industrial data was by isolating it. Either isolation or obscurity. If nobody knows about it, it's okay. And both of those things, isolation and obscurity, no longer an option. Right? If you want to bring it in and do something with it, you are freeing it up. You're taking it out of the environment where it always, the islands it was restricted to. So it definitely creates a new attack surface, a much bigger attack surface than we have ever seen before for this kind of data. Solutions, actually, interestingly enough, at least in my experience, what I keep hearing and going back to are the good old methods, right? I'm not seeing a new silver bullet that kind of takes care of it for us. It's just doing the things that we always did the hard way and figuring out the security controls that we have figured out in the industrial SCADA layers, the security controls that we have developed in the B2C marketplace, putting them together, because this really is a combination of, to my mind, those two landscapes, and we have put the security controls for those two landscapes together to kind of manage the end-to-end solution from a security perspective. But my belief is that when it comes to security in this area, we are still looking at the problem and saying, wow, that's big. I don't think we have quite wrapped our brains around it yet. That's all I had, and I'm on time. We got 5 minutes for Q&A. Questions, thoughts, comments? Does this resonate with what you guys are seeing in your environments?
So if you're gonna, I mean, I'm just trying to come up with how you were gonna monetize your insights into how do you use less water?
Yeah.
With our chemicals, right? You're using around ratio. How do you sell that as a consulting service or as like what is the product you're selling?
Depends on the sector. Yes. Yes. So the question was, how are we monetizing those insights? You know, what are we selling it as a service? What are we really selling in the marketplace, right? What does it look like in the product catalog? If I could rephrase that, right? And for us, it really has been reflection of the industry sector. So in oil and gas, for example, they would pay for a service, purely information service, which will tell them how to extend the life of their asset base in a refinery or how to maximize their production time in a refinery. In some other environments, pools, for example, in a cruise liner, not so much. We use it really just as a differentiating mechanism. We don't monetize it in its own right. We use it as a way to differentiate our service in the marketplace and maintain our premium on the core product. So I think the go-to-market will be very specific. It won't be our choice. It'll be what the market will support. And that's segment specific.
So when you talk about the Internet of Things,
try it again.
when you talk about the Internet of Things, and you talk about the discrete individual things that used to be isolated.
Yes.
Do you see it now more as an ecosystem? So as I reach out to those million things, am I really thinking of it as an ecosystem of not one thing or a scattering of things, but kind of the hive mind, sucking up all this vast that really becomes an ecosystem?
Absolutely. So I think that's so just to replay the question, are we seeing these devices as an ecosystem or just a million different things, separate pieces of equipment? So it certainly isn't, and even historically, even before we started connecting those back to the mothership, they were an ecosystem within a plant, right? So the sensors within a plant had a sense of ecosystem within that context, right? And we actually used those and controlled that as a unit. So that ecosystem concept was there. I think the new opportunity it's creating is if you look at our boiler application, for example, which is deployed in 10,000 different locations and different plants and different environments, that is actually telling us something we never knew before, which is how do those applications behave in totally different environmental conditions, right? So as engineers, we were told to uncontrolled parameters, how to protect yourself from it, control. We are actually starting to learn much more about the uncontrolled parameters in those designs. So it is creating a new opportunity that didn't exist before.
So the follow-on to that quick question would be, as opposed to a static state, this is going to sound a little whack, but are you really recognizing that there's a active entity there? So as these systems are interacting with each other, there's really a, I don't want to call it consciousness, but there's this thing going on that if you begin to peek into it, you really don't understand what is truly going on in that small space or in a larger space, because it's an ecosystem from a living ecosystem kind of perspective.
Absolutely. I think if I could replay that a little bit differently. So the question was, is this ecosystem getting smarter as an ecosystem on its own? Right? Is it learning about itself and trying to manage itself intelligently? I think that, to my mind, if we could get there, we could solve a lot of our problems that we were talking about by taking people. All the problems we talked about were because we were trying to insert people back into the system. Right? If we could get to the point where machines could talk to each other, sort it out amongst themselves, and figure out what action to take, we don't have to deal with half of this problem, or We just created a different problem. But right. So I think over time we'll hopefully get there. But I think this is the path, because if we can't figure out, we can't teach machines to figure it out. Probably. I don't know.
You probably have more questions, but I think, are you going to be here all day?
Yes.
So you can, there's your resource right here for the rest of the day, but we have to cut you off. And I appreciate the talk, and let's give John a hand.
Thank you.